Welcome to this first British Astronomical Association radio astronomy section, GNU radio group. Of course, it's getting longer and longer, these names. Just to let you all know, it's being recorded to go on to the British Astronomical Association YouTube channel. At the end of the meeting, we'll have a chance, if you do want to talk about anything sort of off the recording, that's absolutely fine too. There'll be an opportunity to do that at that point, if you so desire. So the way I tend to run the meeting is everybody will get a chance to talk. If anybody wants to do any particular presentation on a subject, you can either let me know in advance, or usually we manage to find some time in the meeting. Most people that I've been speaking to about GNU radio are excited about the prospect of using it for radio astronomy, but if they've tried it, they quickly became frustrated and having difficulty working out how to use it. So hopefully this will be an opportunity for us all to help each other out, both to understand it, to understand what these blocks are that are in it and how they all fit together, and maybe even to go further than that and make one or two GRC, GNU radio companion scripts, which we can share with each other and make available for the wider amateur radio astronomy community to use as well. So welcome everybody, and thank you very much to Brett in particular, who's 5 a.m. in the morning from Newcastle in Australia, about 2 hours north of Sydney, a bit further north of the Blue Mountains, he was telling me just before we started. So Brett, you were saying that you were interested in the possibility of using GNU radio for interferometry. So do you mind if I get you again? I know you told me before, but perhaps again you could tell us what, as the new people have joined, sort of what dishes you've got and your setup and what you're currently doing with it.
Yeah, sure. Good morning, Andy, and good morning, everyone. I apologise in advance if I'm a little incoherent. I'll do the best I can. I've just crawled out of bed, so a little sleepy still. So firstly, I think the group is a great idea. I think you see on the SARA forum from time to time people asking questions about GNU radio, and obviously there's a lot of interest in it, and but maybe the depth of knowledge isn't what it could be. So it's great to potentially have a group like this, I think, to get people together that have got a similar interest and cultivate some learning and some knowledge. So I think that's great. So look, I guess my setup is a 2-element interferometer at 4.8 gigahertz. I have at the moment on a 6-meter baseline. So we've not long moved to the location we're at the moment. So it's a fairly, I would say, temporary setup at the moment, but still quite functional. Both my antennas track, so I can, I guess I have pointing accuracy to about to say 0.2 of a degree roughly. So I can pretty much point the interferometer elements at any reasonable source, so any source stronger than, say, about 20 or 30 Janskis, and see a interferogram without too much trouble. So 6-meter baseline, one antenna is 2.3 meters, the other is 1.7 meters, just old TV RO type antennas. Use a EDIS 210, a B210 SDR, and I'm using GNU radio with the BAA flow graph that Marcus Leach put together a year or two back now. With pretty much as Marcus designed it, I do make some modifications, just sort of tinkering around the edges with that as needed, but it's very much as he designed it. So the feeds are commercial, off-the-shelf feeds. Waveguide input LNAs or LMBs, low noise blocks, down converters, and which I've modified to take 10 meg inputs so that the two are coherent, and I have just a single 10 meg reference back in the house that I feed out to the two antennas. So I think that's it in a nutshell. I use radio eyes as the way to point the antennas I manually, I have a catalogue in Radio Eyes that I update from online sources, and then I just manually transcribe RA index positions from Radio Eyes across to the tracking control software. So I should mention that the tracking system I use is by a guy in the US. His call sign is November 8, Charlie, Quebec, and he has come up with some great tracking software in a controller, which I find works very well, and I've used now for probably 6 months or so. It works with slewing drives that are typically used to track solar arrays, but works very well for these sorts of antenna applications as well. So, Andy, that's probably a reasonable snapshot anyway.
So in terms of, you're saying you're using a GNU radio script at the moment that Marcus Leach had written.
Yep.
So if I pull up Google on here, would you be able to help me find out where we would find those scripts from? Would that be okay?
Sure.
Okay. I assume there's something that's accessible online, are they?
Let me think where you can get those. In a while since I actually saw some.
If anybody else knows, please. So he did some videos for the British Astronomical Association that are available online, and it looks like a PDF file there that he's done as well. Just pull the link up there so people can see it.
Yeah, so there were two online sessions, and there's information in both of them, I think, which is useful. I'm not sure if it was a GitHub repository or where they came from, to be honest. Let me see if I can find them.
Okay.
If not, I'm happy to, if we create some sort of repository to share information, I'm happy to stick my flow graphs in there.
Okay, perhaps if you send them out to me, I can forward them to other people.
Yeah, no problem.
At the moment, we don't have a repository, but I can certainly I can put it on my website and provide a private access and send folks out the password, etc., to be able to access those. Yeah, so no problems. Ideal. Yes, please do that. Or alternatively, you could load them up in the chat if you had availability to it at the moment. You can attach a document there, but either way works, whichever you prefer. Okay. So, anybody like to ask Brett any questions about this? I think you've bowled everyone over.
Made no sense at all.
I don't know. I was thinking I wouldn't be able to fit one 2.7 metre dish in my garden, never mind two, with a 6 metre baseline on it. So, at the moment, you collect this data, and how is it actually displayed on the GNU flowchart that you have at the moment?
So Marcus's flow graph produces a plot in real time, and also produces a file that you can read and post-process. So what I typically do is just keep a simple log of observations, which would be a date, the name of the source, some information about the type of the observing conditions, and I might take a screenshot of the flow of the interferogram and stick that in the log. But then I do muck around with post-processing data as well. So I use Octave as a tool to do that. So it allows you to do some interesting averaging, which improves the interferogram, and you can do a whole bunch of other post-processing with that as well. So yeah, that's how I use the data.
That software you said was called Octave.
Octave, yeah. Just going to grab a glass of water. Mouth's drying out.
Okay. Sorry. Okay. Right. Well,
Have you ever heard? Have you ever heard of MATLAB?
I've heard of it. Yes.
Yeah. Well, Octave is a GNU equivalent of MATLAB.
Oh, right. Okay. Yeah.
Yeah, it's built. It's designed for open source on the GNU software stack. So just like GNU Radio, Octave is the equivalent of MATLAB.
And was it OCTAVE? Is it? As in a
Yep,
musical octave.
that's it.
Okay, brilliant, brilliant. Thank you very much indeed. That's so. What is it that you would like to be able to do differently with GNU Radio that you can't at the moment? That would help with your interferometry or any other projects that you'd like to do?
Yeah, so I think my interferometer is a very basic instrument and produces interferograms, which is great, but I think there are lots of things that we could do, or I could do, hopefully, eventually, that will improve the performance of the interferometer. So, for example, basic proper calibration of the instrument would be very useful. Trying to understand how that should work, and being able to do that and then share data reliably between other people and groups like this would be fantastic. And so I have no sensible way of calibrating any of my data at the moment, which I think is a bit of a problem. But sort of moving more towards, and eventually producing images, which would be, it's many steps away, and I know a little bit about aperture synthesis and I know enough to know that it's complicated and it will be a challenge. But being able to do fringe stopping and doing other things that professional interferometers do to achieve the ultimate goal of generating images are the sorts of things I'd like to do with it anyway. Mm-hmm. But I'd love to do, given I've got a reasonable size antenna, one of them anyway, a 2.3 metre antenna, which I can track a source with fairly accurately. I'd love to build a pulsar back end and do some pulsar observations as well. So, and I think there's plenty of other things like that we could look at doing.
Yeah, okay. Well, thank you very much indeed. Thank you. I know that Ted has been doing some things with, or attempted to do some things with GNU Radio, and you posted a new video that you've done with about GNU Radio with Ezra. Would you like to tell us more about that?
Actually, that's pretty old.
Oh, it's a pretty old video then. Okay.
Yeah, it's 2 or 3 years old now. I made a translator code to take Dispira data, whatever formats it is in, using GNU Radio, and then push it into Ezra data format. So that's an awkward way to use Dispira, which then uses GNU Radio. I'm now making great success, actually, yesterday, making a version of Dispira GNU Radio script, I guess is the right word, to actually write Ezra data completely. And what I'm trying to do, I hope Brett can help me, how can I mark certain samples moving along through the pipeline that are of reference samples from a different frequency? There's something about tag I read about 10 minutes ago. Have you ever played with tag? It's used in packet stuff.
I have not, sorry. I can't help with that.
Well, that's where kind of where I am. I'll keep pumping you for all sorts of other information. I am struggling with GNU Radio, but I'm making more and more sense, fighting my way through it. What I've put in the chat are the links I posted up on the Sarah email reflector for the GNU Radio seminars that we keep talking about. There they are in order. And the bottom two are where you can get the code. I'm thinking the very bottom one is where Brett got one from Marcus for his radiometer, I guess is the right phrase. There are different words being used, and so I'm trying to use the right words. Does that kind of make sense, Brett? You pulled it off some GitHub site?
Yeah, I'd say that's where it's come from.
And so that's probably on the CCERA website under GitHub, under repositories. He's got a bunch of them in there. And so there are the links to help. I'm making some progress with GNU Radio, but I'm finding it difficult. The hardest thing I found was to darn install it on something more modern. Yeah, I see shaking heads from Dave. You can start with let's do something vanilla like Ubuntu, and then now you can do a GitHub clone. That's good, and then you can build it entirely, and that is the way I got it to work on Ubuntu 22. I bet I could do the same thing on 25. There were worries in the past expressed by Marcus himself saying that GNU Radio was having a tough time catching up to, it might have been 22 at the time, but 22 seems to be working okay, Ubuntu 22.
Sorry, go on. Sorry.
And so I wonder about Ubuntu 25.
Yeah, I've just installed it on Plucky Puffin. Which I think is the latest version of Ubuntu, and it installed without any issues whatsoever. In fact, I was running it on Windows before because the people are using Radio Conda or Conda Radio, I can't remember, and I found that to be an absolute pain in the end. I couldn't load any of my FunCube dongle stuff, so I've gone back to a pure Linux version of GNU Radio. And
I have seen a web page for Radio Conda,
yeah,
using the Python version with Conda. And there's a web page of a guy that makes it. He says it makes it easy. So that's an opportunity. Yeah. Maybe it needed help, was my thinking.
Yeah, it does make it easy because Conda being is basically it's a package manager for its agnostic language, but it is very good what it does, but you're fixed with certain packages, and I found that I could not install particular hardware device drivers on Windows through this Radio Conda. So I've gone back to Linux. GNU Radio was developed for a Linux-based system, a POSIX system. It does run on Windows, but I would recommend anybody in the future get it running on Linux if you really want to do stuff with it. If you want to start patching it, writing your own software and stuff like that, your own scripts, and particular device drivers for obscure devices, then you really need to go Linux. But that's a personal thing. You may be lucky and get it to run on Windows. It depends on what sort of devices you're using.
I'm thinking Windows is the secondary destination for GNU Radio.
Yeah.
I'm excited that it's available, but we're doing the hardest thing of controlling hardware through these operating systems, and they keep moving along. What is the latest version of this Ubuntu with this strange name now?
Let me just get it for you.
Are we up to 26 or something, or?
Talk amongst yourselves. I'll get the actual.
I think I'm using 2204. I've tried Windows as well and found it really clunky and unstable. So I only use Linux. Yeah. Not a Linux power user by any stretch of the imagination, but I'm learning. It's not a necessity.
Plucky Puffin, which is the latest one, is 25.04, and that installed absolutely beautiful. GNU Radio came down and went on perfectly. Yeah.
My biggest problem there was on 22 and 25. On Despera's website, they have a really nice solution that you make this bootable USB drive and you plug it in and presto. But the presto blows up in my face. My problem is perhaps my old laptops don't recognize something so new as a 32 gigabyte USB drive. And therefore the booting process fails in the middle and starts talking about, I can't talk to my SR0, which is the CD disk drive, because of some bug down in the boot code, but I could never get past it. So I spent a month or two on that, and eventually I just went to the build process, and I'm making progress. So I leave all these notes for others following the same path.
So Ted, did you say you're using
I am learning.
Did you say using a 32 gigabyte pen drive?
Yes, apparently this boot drive, this boot USB thumb drive, will fit a GNU Radio, I think with the operating system 22 on there, all on one USB thumb drive. And
Yeah,
that would be great. That'd be marvelous if it all worked. It just doesn't. It throws you in a intermediate, was it like file system something? Anyway, you're lost in the middle of the boot process. It looks encouraging and then dies. So at least in my process. Am I using cheap thumb drives, which are not known?
I just don't understand why you were able to even try and install a 32 gigabyte one. I did this yesterday, in fact. Actually, I did that same installation process. Maybe we're talking about different versions, but the latest version of the ISO for a USB thumb drive come down as a 10 gigabyte ultra compressed 7Z file, which when you extract it is 119 gigabytes in size, but won't actually fit on a 128 gigabyte pen drive. You need a 256 gigabyte pen drive to actually load it up.
I understand. First off, for the 22, it would fit on a 32 gigabyte, but not the 25 version. So I agree with some of what you're saying already.
Oh, there's two different versions. That's why then. Okay.
Perhaps. I thought it sounded great. I have had trouble. Boy, it'd be great if someone came up with it. Other installations for Ubuntu have also had the same problem, where you get into this intermediate world, and so it's not just GNU Radio. It's just a bummer that the hardware just doesn't work completely. And I think I'm just using old PCs as part of my problem.
So can I ask you? So I've now got a working version, which is an ISO that 256 gigabyte drive.
Now you have to tell us what operating system.
Ubuntu.
This is just GNU Radio, or are we talking some other application?
No, wait. It's the Despera one, Despera ISO.
Right, so Despera's good.
It's got whatever comes out with it, which is loads. It was let's say 128. 119 gigabytes worth of it, so it's a bit more than just standard Ubuntu. And I think it's got GNU Radio in it, and I think it's probably got the GR Radio Astro stuff on it as well. I think, I don't know what else is there. I think there's a whole pile of other stuff as well. So in terms of setting that up on, say I've got a dual boot computer, can I just replace the Ubuntu version I've got on my dual boot computer with the one that's on that USB pen drive? Is that easy enough to do, or is that a difficult process?
You're trying to put it beside it, so you have two operating system boot choices?
Well, that's what I tend to do, or do I need to just wipe the computer and just have the one?
I don't know if what I was describing with a thumb drive installation from a boot thumb drive knows about sharing. Maybe it does at the Ubuntu level. I don't know. I never got that far. Yeah. So I saw promises. Beware.
Okay.
Personally, from my point of view, I use these mini PCs that come with Windows as the base, but you can put a secondary SSD inside. And so I boot from the secondary SSD, which is in Linux.
The secondary SSD is not a thumb drive. It's actually some mechanical rotator.
Yeah, it's actually a hard drive.
Okay.
An SSD
a solid state hard drive.
Yeah.
Yeah.
So how do you
Well, that's
choose
why I'm
between
asking.
them?
Sorry?
Is it a solid
Andrew?
state, Andrew?
So I was saying, how do you choose between the Linux SSD and the Windows SSD? Is that with Grub?
But BIOS.
Oh,
You
BIOS.
go into the BIOS and switch.
Okay.
So when you power up the PC, you hold down some button. Mine was F12 until it finally talks about a one-time boot process, and then you can choose. Sure.
Andrew, on that mini PC, do you know what the CPU is on the mini PC that you're using there? Because I just got a couple of them running the other day, and I'm just curious.
Oh gosh, no, it's a Celeron, but I couldn't tell you which one it is.
Is
I
it
can
an
look it
i7?
No, I very much doubt it. These are very
A
cheap.
Celeron. Oh, okay.
Yeah.
All right.
I can look it up for you.
Are we talking all about dual boots here, or are we talking about the Windows subsystem for Linux on later versions of Windows? Because Windows can support Linux out of the box now. You know that, don't you? It's called Windows Subsystem for Linux, WSL. You may want to Google that, so you don't have to dual boot or anything like that. It does come actually packaged with a Linux equivalent.
So let's count here. I've been talking about Ubuntu's and then different versions, maybe 22, 25.
Yep.
You're talking about Windows, which has a Linux inside it. There's a lot of talk about, Raspberry Pis, and then I suppose you got versions there too. So as we go along, folks later on will need those details as well. Oh my gosh.
Yeah, well, most Raspberry Pis are Linux, full stop. Really, you wouldn't. I don't know anybody who's running or tempted.
Oh, I agree, but they're different versions of Raspberry Pi operating system.
Absolutely, and you can run Ubuntu no problem on a decent Raspberry Pi. It does come with its own version of Linux. I know, Raspbian is it? I can't remember what it's called now. But at the end of the day, they're all running the same kernel basically. You know, the Linux kernel is that's it. It's a kernel, full stop, and all the releases of Linux use that same kernel or versions of it.
Am I right to think that kernel is? I'm sorry. What's the Debian?
Yeah, that's another version. They all use the Linus Torvalds or whatever his name is. I can't remember now. The people that write the Linux kernel. That's it. You can go to their website. And if you want to develop your own version of Linux, for example, Red Hat, Debian, Ubuntu, SUSE, whatever it's called, they all use that same kernel or different releases of it, but they wrap it with their own tool sets and all the rest of it, and their own look and feel, etc. And to make life even more complicated, GNU, or which is basically generally not Unix, was a set of open source tools that was written to make it easier to get away from Windows and being locked into that awful system. Yes, I say awful because I hate it. It open sources everything, and what happened is they wrote their own micro kernel which emulated Unix. But at the end of the day, it was called Linux. And then along came Linus Torvalds and that, and he wrote the actual Linux kernel, which then bundled it in with the GNU stuff, which is all based around what GNU Radio and Octave uses, and that sort of blossomed into what we now call Linux. It's a very complicated story, but I think the problem is we keep mentioning Windows, and if you can get away with not using Windows, and especially sticking Linux on top of Windows and virtual machines and stuff like that, I would just try to keep away from it. And at the end of the day, and your life would be it's that learning curve, I know, but once you've got rid of that, any scientific technical software written as open source through the universities or whatever would have been written for Linux, Unix, POSIX-based systems. They're not written for Windows, full stop. But you get all these wonderful people out there will bend it and add software to these packages to get it to run on Windows. And usually it works, and then eventually a driver goes amiss or whatever, it falls over and you're stuck. Sorry, that's my rant.
I agree with your comments. To be complete, I want to say Debian, Debian, was the root of a lot of these things, for those listening later on.
Okay.
Right, so I think we've all agreed that GNU Radio probably works better if you run it natively in Linux rather than on Windows.
Exactly, Andrew, yeah.
Having said that, David Hardwick from the BAA and myself spent 3 hours last Wednesday afternoon trying to get an SDR Play module to work on GNU Radio for Windows. At the end of 3 hours, and with a rather large headache, we succeeded. It was amazing.
We did, didn't we?
I've heard many stories where Windows will come now, do an update, and then replace your driver, and so you start again.
Just kill the updates. I had an update on Windows that destroyed a laptop. It just wiped my SSD. I'm still struggling to get that laptop back up and running. It's just incredible. Yeah, those updates from Windows, that whole system just keeps getting more and more just tyrannical, is the way I look at it.
Yeah, exactly. It tries to be too clever. It really does. Yeah, and it's.
Yeah. If Dave here hadn't helped me out, I would have never managed to have got that working. So, I'm now, Dave, trying to get the SDR Play module to load on the Linux version, but that's a different story. I need to contact you, okay?
That's on the disk I sent you.
Is it? Okay, it's on that version. Fantastic.
The whole suite is on there.
Oh, brilliant.
And I'm sorry, which version?
So it's Ubuntu 22.04 with GNU Radio, Radio Astro, SDR, Play 3, Blade, AirSpy, the whole lot.
All right, because that I'm going to arrived this morning, so thank you very much for that. Yeah, thank you, brilliant. So I will put aside the Despera distribution. Did you base it on the Despera distribution, or just set it all up yourself?
I did the manual download off GitHub.
And what do I do? Just install on a spare computer straight off the SD, do I? Yeah.
That's a bootable drive. So if you've got a PC that will boot from the micro SD, you can plug it in and it will boot from it.
All right. And can I also use that to install on the computer, a more permanent copy on the computer?
You'd have to clone it.
Right. Okay. Okay. Well, thank you very much for that, and thanks.
Sorry, may I just ask, what are we talking about here? Despera, what's this?
Oh, Despera. Yeah, good point. Let's look up Despera and show you. We've been using these terms without explaining them. That's a very good point.
That first video I posted gives an example of use and such, if you want.
Okay, thanks.
So,
it's a West Virginia University radio astronomy place.
yeah, so it was a program developed for teaching, but what really, and it's got all sorts of things like how to design and make simple telescopes, but what really seems to help is it's got a whole pile of lessons which can be quite helpful. Some of them more general stuff on radio astronomy, and some of them are more specific. And then alongside that, it's got a GitHub repository, which is enormous.
Nice. Yeah.
Which I'll just pull up and just show you. So if we I can't quite see it on there, but somewhere you can actually get down to the different parts of it. It's got piles of stuff on there and piles of downloadable things as well. Okay.
Thanks.
Okay. So who have we not got? So we had Brett. How about you, Steve? Would you anything you'd like to talk about?
I'm delighted to hear all the talk about Linux. If you notice, I'm really new to. Yeah, there you go. I worked for them. I worked for them for a while.
Oh, you did? Wow.
Yeah. I had lots of fun back in the day trying to get Linux to boot on a Windows machine, and in the end, the only thing I ever found that worked was just to have Linux on a hard drive and forget Windows ever existed. And so that's my 2 cents worth. I'm actually a student doing a degree in astronomy, and I came across Dr. Thornett on a SARA call the other day, and I thought, oh, this sounds like my tribe, and here we are 38 minutes in. It is. So I don't have anything other than to say Linux for the win, and thank you for inviting me, Andrew.
Yeah, sure. Do call me Andrew. Don't call me Dr. Thornett. And at least
I'm terribly sorry.
No, it's fine. I am still technically a doctor, but I'm a medical doctor rather than a PhD doctor. And actually, I retired on ill health grounds about 4 weeks ago. So when this year's registration lapses, I'll cease to be formally a doctor. But yeah, it's very nice of you to say it. But anyway, thank you. But just call me Andy or Andrew. It'll do fine. So what are you hoping to use GNU radio for? Anything
I don't know yet.
Oh, right, great, fine. That's fine too.
I'm right at the beginning of my journey. I'm sort of toying with using the satellite dish on the top of my house, which isn't doing anything.
Mm-hmm.
And that's as far as I've got. But possibly, I've read a lot recently about measuring velocities in the Milky Way just by sitting there and letting it come to you. That sounds like my sort of speed. But anyway, I'm trying to think of something for my dissertation in 7 years' time.
Oh, what dissertation is that?
That was part of my degree.
Oh. And what's the degree that you're doing?
A degree in astronomy at University of Lancashire.
Ah.
It's the distance learning one that means I never have to go anywhere near a campus. Ironically, I'm right on the doorstep of UC Santa Cruz and the Lick Observatory, if that means anything to anyone.
Yeah. Wow.
It's funny that I have to go 6,000 miles to get an education.
Yeah.
I can't enroll at UC in the UC system, the University of California system, because I've already got an undergrad degree. They don't let you do a second one.
So Lancashire's been doing that for a long time now, haven't they? Yeah, because we used to go to Astrofest 25 years ago, and they were advertising their degrees, remote degrees then. Yeah, very good. I remember doing a couple of courses.
Yeah, so, there's hundreds of us on this one course that I'm involved in.
Yeah, I think they still go to Astrofest, Dave, and still advertise it. Probably at the same table.
I did a quarter of a century of Astrofests and sort of gave up in the end because it got a bit sort of commercial. But you can only have Brian May turning up and signing autographs, so often. You just sort of hang on, I've had enough of this. The Lick Observatory, that's the one right on top of the mountain there, isn't it? At the back. Is that right? A long, windy road. I remember going up to it. Is it still open then? Or?
Oh yeah, I mean, you can go in there anytime you like.
Oh wow! Yeah.
So they give guided tours on Thursdays and Tuesdays or something like that. And guarantee I can't remember. And every time I go up there, no guided tour, but it's 365 turns to get to the top.
I remember driving up many years ago, thinking, "Wow, this is a long way."
It is. So it's 18 miles, but it takes an hour.
Yeah.
Wow. Okay, Andrew, that's a chance for you to tell us what you want to say.
I've been using GNU radio for several years now, especially the Despera stuff, looking at interferometry as well as hydrogen feeds. Let me see if I can share without Entire screen.
While you're putting that up, just to say, Steve, that you've got Ted on the call here, and he is the expert par excellence at drift scanning the Milky Way and actually, as you said, use your terms, letting it come to you so that you do mapping exercises and demonstrate dark matter, etc. And we also have a separate hydrogen line group, which is designed to help people get started in that area. So you'd be more than welcome to join us there as well if you so desired.
Oh, fabulous! Thank you. I appreciate that.
So assuming you can see my presentation, I'm assuming you can.
Yep, you can.
Yeah. So this is just adding interferometry. This is from two 750 mil wide aperture feed horns, just galvanized steel funnels, and I varied the distance between them from 2.5 meters out to 20 meters, just to see the effect. And this is observing the sun. And so these are the sort of results you get. You get the interference pattern that you see on the right-hand side zoomed in. And the further apart you put them, the more resolution you get, so the more signals you get in each of those. But that was just observing the sun. And that's an adding interferometry. And if I change to the next one, this is a multiply interferometry, which does the same thing, but you get slightly different results with that. And so this is just using straightforward the Spira interferometry units. And then in terms of my device, so
which software-defined radios are you using to collect the data?
So do you mean the SDRs?
Yeah.
Those were probably AirSpice.
Yeah. Okay.
And so this is my mini PC. I've just remoted into it, and if it will boot up, then it will boot up to GNU radio anytime now. Always slow. There we go. And that's one of the scripts from Dispira for collecting hydrogen line material, and I've done my own out of 3 modules to, instead of saving individual files, I can save and append data to a file to save space on the hard drive. And so, yeah, I just mess around with this. I don't know too much about the guts in the middle here. I just fiddle around with how the data comes out. And then when I do get the data, let me stop sharing, I take it over into a Windows machine, and using C# I can then write my own software for doing analysis and processing.
Brilliant.
I'm eager to see more of that processing too. What kind of outputs are you playing with? What do you come up with?
I take a whole series of data files, and then I process them into a 24-hour time script. I do the, I don't know whether I've got an example in this presentation or not. Probably not. That'll do. There. So it gives you the.
We can't see your screen at the moment.
You can't. I'm not sharing, am I? That would explain it. That would explain it. Share entire screen. Ding, ding.
Sorry, while you're doing that, explain how did you say you collected the data over 24 hours?
So you just leave it running. I have a steerable dish. It's got a spin rotator on it, 1 degree accuracy. But typically for these, I just leave it pointing south at an elevation, and then just collect the data over 24 hours. And so the Radio Astro just spits out a file. You can define what integration frequency you want. Typically, I put 30 seconds, and it spits out a file, spectrum file, every 30 seconds. Over 24 hours, you take all of those, and so along this x-axis are all of the individual 30-second spectra over the 24-hour period, and that's what you see in the contour plot. And in the plots above, you can see either frequency or the velocity of the signals that you're looking at in that spectrum. And then in the middle, I've got this sort of radar scan showing you roughly whereabouts in the Milky Way you're looking at. So that's the sort of processing.
I mean, your data looks stunningly detailed. So what size is this? A single dish, isn't it, or single antenna?
Yeah, it's a single dish, 4-meter dish.
Ah.
Yeah. And AirSpy or whatever. So. And
the declination changes, or perhaps to say the elevation changes. How many? Well, is it these are a degree or quarter of a degree, or what each time you change it?
It's a degree accuracy.
So
I'm going to stop.
So for the sake of Steve, I think, who's never done this before, perhaps we ought to explain that with these drifts. And correct me, Ted, if I've got this wrong, please. So the basic principle of these, what they call drift scanning, is you have your aerial, or second in America, antenna, and you basically aim it at the sky, make sure you know what direction of the compass it's aimed in, and what, use a digital inclinometer or some other system so you know exactly what angle it's pointing upwards. And then it just left at that same position. You don't move it around. It just 24, 48 hours. You can, in my case, I do them for a week at a time, so that get slightly improved signal to noise ratio, but basically at least 24 hours. And then whatever software you've got cleverly extracts each point in that 24 hours, because obviously the Earth is rotating, so you're getting data from different points as it rotates. It's like you've moved the telescope around. The Earth does it for you. You have Andrew there was talking about integration time. So clearly the Earth is rotating. So just like when you're taking a picture in astrophotography, you need to decide how long you're going to point at the object for and collect information for all your photons for. And the same here. But of course, the Earth is rotating while you do it, so it's a trade-off. The longer you collect data, the brighter the signal, but also potentially the more slurred the result is. So you're trying to get what is perfect for your. In each antenna will have a different, depending on the size of the antenna, will have a different ideal integration length in that way, and then once it's done for 24 hours, you then change the elevation, so it now does another 24 hours, different part of the sky, and you keep doing that time and time again, and you build up the pictures like that, and then you can magically press buttons, or you can be really clever and do it yourself and start generating maps of the Milky Way, etc. Or you can use TED software, press a button, get 250 diagrams, and then sit there trying to pull out what little hair you've got left while you're trying to work out what each of the diagrams tells you. But you don't need to worry, because Ted's great. So you just book him in for another meeting, and he spends another 2 hours online with you telling you what they mean. It's brilliant.
Now remember, you get all that frustration for free.
but Andrew here is the sort of person that writes all the software himself, so he doesn't need to bother with TED stuff. But me, I don't understand most of it, so I just follow somebody else's footsteps. But anyway, now he sent me his stuff here for GNU Radio, and I can copy that. Marvellous. I'll plagiarise anybody. So thanks very much, Andrew.
Is that software going to be posted somewhere? The Andrew, your software that you've written?
I'm selling copies on eBay. So I've got my first auction started tonight.
I'm not a software engineer. I'm a jack of all trades, and so I don't write professionally. But if somebody wanted a copy of the Windows software for processing the GNU radio stuff, I'll happily send it to you. It's written in C# in Visual Studio.
So the one you sent me is for using it in Windows, isn't it, rather than Linux? Is that right?
The disk I've sent you is the Linux build with
Okay.
all of the acquiring software on it. It's
Okay.
got no processing software apart from EasyRA is on there as well.
Yeah. Okay. Marvelous. Thanks.
So you say it has the driver for the various SDRs that are out there?
But what I've given Andrew, yes.
Wow.
Yeah. Yeah, I even put Blade on it because Nuant Blade is a dual receiver that I've got. Expensive, but I've been playing around with
Yeah,
that
pretty
as well.
high end.
Yeah.
Well, I mean, I was excited. I'm completely out of the water on any of the software stuff, but just seeing Andrew, was it yesterday or the day before, and the RTOP getting the RST Duo to work with GNU Radio, that was really exciting. And I've got the same SDR. I would really love to be able to get that thing to be able to record some data on it. So, gosh, any software that's out there that's usable with it would really be fantastic. And I don't know, Andrew, if you're going to be talking if you're going to be talking about that process at all today or not, I'm not sure.
Well, I was going to mention it if people wanted to hear it, but I was giving other folks a chance to talk.
Oh, okay,
Talk first.
sure.
And then if they decide they've had enough and they want to disappear, they can. Or whatever. How about yourself, Dave? Shall we? What would you like to say?
Yeah, sure. Well, I've been asleep for about 10 years because I used to use GNU Radio 10, 12 years ago, and I put it all to bed for some reason. I can't remember now, but I got on with other things. But recently, I just retired. 50 years writing software. Yeah. Then you retire, you keep writing software. But my last company I worked for was General Electric Aerospace. So we did I have a lot of experience with Python and C, C++. So I know the bones of GNU Radio. So if any of you guys want any out of tree modules written, anything like that to enhance the performance of your software pipelines, we can do that. Not a problem. So yeah, my background's mainly software and computing systems and digital signal processing, stuff like that. But again, I am jack of all trades. I love astronomy, sort of space, anything space themed. So I read a lot about it. I do a lot of visual observing. I'm not a huge amount of radio because I never managed to get a big enough antenna, but to do what I wanted. But listening to you guys and what you're doing with interferometry or planning to do sounds really exciting. And on speaking with Andy recently, it's re-sparked my interest in GNU Radio. So I'm getting it all loaded now and diving into to GitHub and looking at the software, what it's all about. And it is, GNU Radio it's all written in C, C++ at the back end, because it has to be, because it's fast. But now it's all wrapped up in Python. So basically it's Python extensions. So it's a great package. And as I said, if there's any software you want to have written or we can discuss and talk about, I'm happy to dive in and help you guys as a team and so on. So.
Brilliant. Well, thank you. Thank you very much indeed. I think you might live to regret that one.
Yeah, I think so too. I've got to say, I enjoy doing it as well. So it's yeah.
You know that long list of extra tasks for EasyRA that you've got there, Ted, that you never get around to doing because you've got so much on. You've got a volunteer here. Just pass them straight over to Dave, and he'll have them all done by next week for you.
I took full note of this. We'll be talking. I have a list.
George, you were latish joining the group, which is no problem at all, but it meant we didn't have a chance too much to say hello this morning, so this evening, so it's lovely to see you. And where are you logging in from this evening?
So I'm at Siena College near Albany, New York, and we have a small radio telescope that we've been trying to work on as an undergraduate student project. We've been trying to replicate. MIT has a nice program called Small Radio Telescope. So they give you instructions on how to build a receiver. But then we've been trying to use GNU Radio to just sort of design the back end, the data collection, and then the how do you process the data? I guess more just how do you collect? So we've been trying to use just different receivers. We've tried out the higher end UHD. We've tried the small dongle thing, and then the SDR RSP1 in the middle. Mostly trying to do 21 centimeter, just map out the galaxy just to see that it's there. But certainly interested in learning to do some other things. If we could learn how to do interferometry, that'd be cool.
Okay.
But yeah, it's a little bit of a learning curve, but making our way through it.
So
Also, have been trying to use Despira, but I just keep running into just small problems with loading up libraries and that kind of thing. So we have the stuff to do it, I just haven't got it to work just yet.
So
George,
are you a
I've been down
student? Sorry, carry on, Ted, carry on.
George, I've been down that full path, starting with SRT from MIT. I still use it to control the dishes behind my ears here, because it knows how to control the motors so nicely. And then I convert that data into my format for Ezra to fully process it after that. So we could talk about all those kinds of levels. I suppose I used the old SRT that ran on Linux. I'm not sure that makes a big deal of difference, though. Please contact me. That Ezra page has my email at the bottom, if you want to. Otherwise, there's lots of learning by bumping your nose, yes.
So George, are you a student or an educator there?
I'm a faculty, so my background is in modeling chemical species that are observed by things like ALMA and stuff like that. So I, can solve the differential equations to do the chemical modeling. I got sent to a workshop to learn how to use Arizona's 12 meter. So for Siena, I'm the expert radio astronomer, so I don't really know much, but sort of learning as we go and just running into bumps. One of the most useful things I did a couple years ago is that Princeton University has a really nice, they've taken over a World War II radio dish near the beach in New Jersey, and kind of the same thing, just learning by doing, and they have a whole lot more capability than what we do, but that was really the first exposure to using GNU radio to collect data anyway. So I've tried to sort of modify what materials I got from that.
No, brilliant. Very interesting indeed. Anybody else like to ask George any questions or make any comments?
You said you use the RSP1 in one of your receiver chains?
Yeah, that's right.
Is that the 1 or the 1A?
I think it's the 1A. I have a few of them. I have a 1A, I want to say a 2 and a duo.
Okay.
And I think once I got the 1A to work, then the others work just as well.
Yeah, I was just curious, because I have an original RSP1 and not an A, and I understand that there was a pretty significant upgrade on the RSP1A and sensitivity and whatnot, and so I was just curious if which one of the two you were using in terms of the differences in between the two models and the sensitivity that supposedly was improved on the A model. So I was just curious what you were using.
Yeah, it's definitely a 1A. I don't think I've ever had a 1, but it's really very, very powerful for the price.
Oh yeah, they're
really
really
do a lot.
fantastic receivers. I have that original one, and then I have also an RSP2, and then a Duo. I have 3 of those guys, and it's the Duo that I'm really interested to get running, and this is kind of what Andrew has just been working on and had some success just the other day. So I'm really looking forward to see how I can maybe latch on to that. I'm completely out of the water here. I mean, I'm not a software person, so I'm just completely out of the water and 99.9% of all this stuff, and just kind of diving into a concrete pool is what it feels like. In terms of my brains, feel like they're exploding. I'm actually a molecular biologist, so you name me a gene and I can clone it with my eyes closed. But go to software and GNU and Linux and Debian and so just trying to pick up. But anyway, yeah, that's great. Fantastic. Well, good luck on getting those systems running.
Right. So I was just thinking in terms of Sunday evening. It was. Oh, is there anybody else here? It was yourself, Adrian, and myself. You weren't there, were you, Andrew? Or were you after Sarah? No. No. Okay. So and Ted wasn't there, I think. So I'm not hoping to bore people too much. So I'll just very briefly say what we talked about after the Sarah meeting, then, and which Adrian and other people gave me a great deal of help with, which was very much appreciated. So. There's this one that Adrian and I've been talking about. Can you see it? The RSP Duo. So this is a SDR Play. SDR Play is actually Moonraker, so it's actually a British-made one, which I'd like to say it means it's better than everybody else's, but it doesn't, of course. But nevertheless, support my local people. So you've got a USB cable at the end. You've got a clock reference in and out where you can use it to join 2 together if you want to, or have an external clock. That uses an MCX connector, which I've discovered if you buy any MCX cables in the UK, they cost an absolute fortune. So you better.
Andrew, I've got a tip for you on that. There are these fairly cheap external GPS antennas.
Oh yeah.
That can be used. It's essentially the LNA. It's like a little external LNA that a lot of GPSs you can plug into for receiving the GPS signals, and quite a number of those, and they're fairly inexpensive. And just about all of those guys have a cable with that connector on it.
Oh.
So if you could get a hold of some of those antennas and buy 2 of them, and just splice, just cut them off and then splice them, because I know you were talking about the difficulty getting those cables. But if you do that, because I've tried it on my Duo. And I've got a couple of those GPS external antennas, and it's a perfect fit, that MCX connectors. So the only thing is that you would have to cut off the cable from the GPS antenna, and they're usually fairly long cables, so you got plenty of cable to work with. And just, of course, get the 2 ends with the MCX, and they just splice them together. And at that clock frequency, just a really connecting the 2 coaxes together shouldn't have any problems. Because that's only 10 megahertz or something clocks. So anyway, that might be a cheap way of making yourself a cable for tying those receivers, for synchronizing them, and actually getting a cable without having to use any adapters. So I just thought I'd pass that on.
Okay, thank you very much. Thank you. So on the other side, we've got 2 inputs for the two options. So I've just connected a cable on here for convenience tonight, and then we've got. Share my screen. And I did have. Where's it gone? It looks like it's crashed out. So we'll start again. Just waiting for GNU Radio Companion to load up. Here we are. So this is actually this one's from the Dispura distribution, but I'll just start with something more simple because, as was said before, I don't really understand most of this either. So let's start the basics. Where are we? Here we are. So that's my simple GRC thingy-bob. So we've got that plugged in. I eventually on this window managed to get the SDR Play one to work. So in terms of anyone who's interested in using an SDR Play module on the GNU radio companion called GRC, basically it's if you ever used a what you see is what you get HTML editor in the past, this is exactly what this is. You shove the blocks on and then you press this play button in the middle here, and it compiles it into Python and then runs it for you. So you basically stick some blocks in. So this clearly is a block which actually collects data, and these sync things are blocks that do something with the data, which basically display it for you. And you can have on them a number of options about what it displays on the chart. Unlike something like Spectrum Lab, where you can change it on the screen once it's running. This isn't always the case in GNU Radio. Many of the blocks you have to put it into the block before you run it. And also the other things, if you look here, there's a center frequency, etc. So, and there's also a center frequency on each of the tuners on the SDR Play block there. So you need to match the two together. So although it sounds very logical, it doesn't necessarily transfer information from one block to another block. You can choose your blocks on the right hand side, and we've got a nice little search button here which is at the top here. If you sometimes that doesn't seem to appear. If it doesn't appear, just press Control F and it appears. And now you can just type in what you fancy. So if I want SDR Play, this brings up all the SDR Play modules that are available. And you can see that there are in fact two modules. There's the SDR Play 3 module, and then one of the core modules, so which obviously didn't come with the core distribution of GNU Radio because it's not in the core selection here, which has a SOAPy SDR Play. We could not get, this is what Dave and I spent 3 hours last week trying to get this to work. It couldn't work, and I get that to work at all. And I've concluded the reason for that, if I pull the module across here and dump it, and we pull it up, is weird in as much as you haven't got a drop down menu and you have to put some blurb in here, which you have to look up, and it tells you in the documentation. I think it's here, so someone click the documentation page, and it tells you what you have to write in there. But I think the problem is this particular module wasn't written before they had the RSP Duo, so it will work with some other SDR Play devices, but not with that. Whereas the new SDR Play module itself, as you can see, works with a whole range of different devices, and you choose the one that's specific for it, which is great, but you have to find out how to actually install it. And effectively it's got dependencies in Python which you need to get working, and a big driver called the SDR Play API, which you need to get the recent one to work. It sounds easy, but turned out to be quite complicated when we were doing it. Anyway,
all these things sound easy after the fact.
That's right.
Andrew, could you double click on the left box for us to give us the details inside?
This one? Yeah, I will do. Just get rid of this one first. If it's red on the screen, that means there's an error on it. And here, this button here where the line is, you can press on it and it will do a check to find errors. But as you can see, it may not be that easy to work out what it means by the errors that it's telling you, but still. Let's get rid of that. So double click on this one. So on here, you've got the option to choose, I don't know what you put in the top, you don't really need it though. The mode, you can either have it as independent. I'm not quite sure yet what diversity does. So perhaps somebody can explain it to me, but you've got two different dual tuner options.
Yeah.
And you've also got a single tuner option where it basically, rather than having two inputs, you get a single input. And the difference is the single tuner gives you a 10 megahertz bandwidth, whereas if you go for dual tuners, each of the dual tuners has a has a two. I think it's 2.5 megahertz bandwidth. Sorry, you're going to say, Adrian, what the difference between independent and diversity is?
Yeah, I believe diversity, what they use is they actually use both receivers on the Duo when you're listening to one signal, and that's useful like in shortwave when you get a lot of fading and stuff. And so by using the signals from two antennas and combining them, you essentially enhance and improve the signal reception. So it's essentially kind of like combining the two receivers into one output to give you a much cleaner signal. If I'm not mistaken, that's the protocol of that diversity.
So would this allow you then, with diversity, to actually essentially create a mini array by having two different receivers, perhaps two dishes or two whatevers, two Yagis?
Excellent question. It seems like it would be something built in Connect and I guess it's obviously in your GNU selection here. That could possibly be a means to arrive at combining the reception from both receivers. You might want to look it up, but I'm pretty sure that's what that is, because I know I just remember reading about that. But that might be built in to be able to do that, combining the signals from two separate antennas. I'm not sure if it's frequency restricted in some way. I don't imagine that it would be, but something to look into, definitely. Yeah.
For what it's worth, 20 years ago when I was working on smartphones, we mandated having multiple antenna, and the word we used there was diversity. So what Adrian's just said fits with what I thought it was going to mean.
Okay.
And you get an increased signal-to-noise ratio as well, for what it's worth.
Sure, yeah.
Right, because I can see a potential advantage, because the other day I was speaking with Wolfgang about, or at least it was one of the SARA meetings, and Wolfgang was on there, and I think the question came up whether it was useful to, because you might remember, my antenna, I've put in two monopoles at 90 degrees to each other, and it was how you actually connect them, and I was going to connect the two of them with a phasing cable in between, but Wolfgang was concerned that would lead to feedback from one to the other, which would then rebroadcast inside the container and create problems. So I was thinking, if that is a serious risk, then this avoids that potential difficulty of just connecting two antennae together. But anyway, there we go. So the master, there's two masters there, and there's a slave. Does anybody know what those mean?
Yes, that's when you connect the two receivers' clocks. So one of them will be the master clock, and then the other one will be the one that's receiving that clock signal, your slave, and that's the one you're syncing with when you connect the clock outputs on those RSPs. I don't know if that makes any sense, but that's the way I understand it.
So I don't understand how this fits in with this module. How does so you connect the two, physically connect two of them together by a cable. One's in, one's out. But what would that mean?
Well, you just have the two receivers synchronized, so that you wouldn't, and especially like if you're doing the interferometry and so forth, or you want the two signals in a phase relationship.
Actually, I can see what it is. You can choose master and slave. You choose one signal, and you choose whether it's coming from the master one or the slave one.
Exactly, right. So you choose one receiver as being the master, by the master clock, and then the slave is the receiver that's then utilizing the clock from that master receiver instead of its own internal one.
Yeah, I think this might be just take which signal you're going to record, because I think I read somewhere that the two receivers will automatically create, if you've got a cable going into the in, it will automatically turn over to the clock signal that's coming into that, I think.
Okay.
Anyway, so we've so this was the sort of simple. If I press the run, Oh, sorry, Ted. Is there anything else you wanted to see about that before we carry on, Ted? You were the one that wanted to see that. Do you want to see what's in the other options? We've got advanced here. I'm not quite sure what those ones are.
How about gain options? So you can put it up to 40, it says. All right.
Mm-hmm.
Yeah, it does have a built-in LNA so that you can adjust the amplification on it. And I don't know if that one also has IF gain. Is it? I might be confusing with it.
Right there.
Okay.
Second floor.
Yeah, it's hard for me to see the page. Okay, yeah. So yeah, it's got both the IF that you can adjust the gain and the LNA. Yeah, since I'm not familiar with this software.
So there's an other tab as well? What's that? Oh, mysteries. Okay. Thanks.
Oh, the frequency correction, of course, that's to adjust for the offset on your internal clock. So if you have a reference signal that you know exactly the frequency, then you can adjust the offset on the clock, on the internal local oscillator, so that it matches exactly your accurate reference frequency.
Thank you, Andy, for finding this stuff. That's great. I'm making notes.
Oh, don't thank me. Thank Dave, and also thank Adrian and crew in the After Sarah meeting on Sunday. I'm the lucky recipient of all the great work they do. Although I must have worked hard with Dave on Wednesday last week, because I did come out with a big migraine at the end of it. But still.
But Andrew, when you get familiar with GNU Radio, you can convert a lot of these things into variables, which you can then pass from one thing to the other. So if you notice at the top it says variable sample rate 32K,
Mm-hmm.
you can make your frequencies into variables, which you can then pass directly into the receiver blocks by using the same variable name. And you can also use choosers and ranges so that you can actually change them on the live running application.
So I think this one might be based possibly on the Dispura one or from somewhere. So that perhaps shows, I think, quite a lot of the sort of things you're talking about. This explains these variables here. Is that what you're talking about?
That's right.
These variable blocks?
Yeah. And then individual blocks in the running program will reference those variable names.
Oh, I see.
So that you pass the same information to the appropriate blocks.
Well,
this particularly one you got from me, Andy, just for others, and it needs a lot of help.
Well, still, it shows the things that Andrew's talking about there. Anyway, talking on here, if you look on this particular block, you can see it says RSP selector. It's actually got a number on there. I happen to have two of these RSP duos, and there we are. So here, what I've done is duplicated the signal processing, and in each, it seems to have been lost. Hang on, why is that lost? That was working. I don't know. Anyway.
Hey Andy, sorry to interrupt you, but I'm going to have to shoot through shortly. The family's going to wake up here, and everything's going to be very noisy very soon.
Yeah, well, I'm just going to finish. Just going to press this button and just show you on the right. We've got a processing thing going on, which is actually compiling it, and then you actually end up with a screen that comes up and shows you your signal. Obviously, you could have different blocks. Anyway, that's all I wanted to show anyway. So thank you very much for taking part, Brett. Before you go, there is one thing we need to talk about, which was that you asked if possible that we have the meeting booked on the 27th, and I know there are a number of people coming along to that. who couldn't make it today, so probably leave that particular one. But thereafter, you were asking whether it's possible to consider a different time of the week. When
if
suits
it's
you
early
best?
like this for me, a Saturday morning or a Sunday morning's best for me. But if we can push it back a bit later, then any day of the week I can probably cope with.
By a bit later, you mean?
An hour or two. Even just an hour helps.
So rather than being 7 p.m. British time, it would be 8 p.m. British time. I'm going to work that one out because where you.
I don't want to cause grief for everyone, so I'll try and work it around you guys as much as possible.
Try and work it out. I've got to get my head around British summertime ending, which is what will happen at the next meeting. So we'll leave the next meeting as it stands at the moment, the date and time, but thereafter it would mean we're UTC +1 at the moment. So according to my clock, we're 2023 and we started at 7 p.m. But in actual fact, that's UTC +1, so that would have been 6 p.m. And you want to put it back perhaps a couple of hours to 8 p.m. UTC. Is that what you're trying to say?
Yeah.
And preferably at the weekend, but you could probably do that on any day of the week if necessary. How do other people think? I mean, you don't have to necessarily just bowl over and agree. We're just trying to find the best time to suit as many people as possible. What's the general consensus?
I think it's pretty easy for us here in the U.S. because we started at noon today.
Right. So.
And I'm at noon now. I'm 1 hour past Ted there, but yeah, it's fine.
Steve, George, I mean, it's a big place, America. I'm never quite sure who's in what time over there anyway.
I'm on Pacific time in California.
Oh, okay.
Does that mean a couple of hours later will be fine for you?
I'm in San Diego, by the way.
Oh, hey, great. I actually work stupid hours, so I don't care what time you set it at, I'll be there.
Okay.
I'm very easy.
What about yourself, George?
Yeah, that should be fine. I'm pretty flexible.
Okay. And
Probably
Dave and Andrew,
there.
then the UK contingent. What do you guys feel?
Don't worry about me. Just let us know when.
It doesn't matter. I mean, weekends probably easier, less conflicting meetings. But yeah.
So what we're saying, 3 a.m. British time at the weekends. Is that what we're saying?
Yeah.
Okay. So 8 p.m. You say. So is everybody okay with weekends? Okay. So let's just set the third meeting. So we got 27th of October. So hey, what? How about by weekends? Do we mean Friday or Saturday or Sunday? Which day suits everyone better?
It wouldn't be Friday for me.
So how about Saturday the 22nd of November? Would that suit it? I'm just pulling one out the air here.
That one I can't do.
Okay.
But don't have to stop for me. I could do the 15th or 29th.
29th. How does that suit?
Yeah.
Everybody okay?
That's fine by me.
Okay, so we'll set the third meeting on the 29th of November at 8 p.m.
I think we've got to let Brett go.
Yeah,
Well,
thank you very much, Brett. So
I've been running an observation in the background. If you want to have a quick look at that
okay.
on my interferometer, so I'll share that quickly if you're happy
Yeah.
to look at that.
Yeah,
and
go
then
for
I'll
it.
disappear. So this is can you see that okay?
Yeah, we do.
So this is the Orion Nebula. It's just gone transit, just past transit here at the moment, but I'm tracking this. So that's the output of the complex correlator from Marcus's program.
What frequency is that at?
This is at 4.85 gigahertz.
4.85.
Yeah, and I'll just quickly show you the.
So that's
It's
just
amazing that it stops so abruptly that way.
Yeah, I'll go back to explain that. So this is the tracking software I'm using. So you can see the two antennas are are tracking the source in real time at the moment. So this is all off-the-shelf software, and off-the-shelf system.
So you're just detecting Continuum from Orion?
Correct.
Wow.
Yeah.
Can you go down to 1665?
No, not
Okay.
with this system, but
Not with the LNAs you have. Too bad.
Yeah, that's right.
Yeah, I specifically, I'm just sort of focused on Orion because the molecular gas cloud has these incredibly loud masers at 1665.
Love to
And,
play around with that.
Yeah, I've been able to map those with the as members of SAR, we have access to that Green Bank Skynet 20-meter radio telescope. And I've done some raster scans of that, and just shows up really beautifully the Orion molecular gas cloud at 1665 megahertz using those hydroxyl maser outputs. But anyway,
Yeah, that sounds really interesting.
Yeah.
So Ted, the reason what's happening here is the antennas are slewing to the source, and then they're passing through some sort of hot areas around the house, and then when they're on source, you start to see the interference pattern. So the real data scrolling in on the left-hand side.
That's incredible.
This is seconds ago. That's not forward time. That's backward time.
Correct.
Okay.
Yeah.
That explains a bunch.
Yeah.
I didn't realise you could do interferometry on extended sources like that. I thought it had to be point sources. Not quite sure where I got that from.
Well, this more or less is the point source. This isn't. So you're right. If you're thinking about hydrogen, you can't. But this more or less is a point source.
Yeah, well, that molecular cloud spits out frequencies at all kinds of all kinds of frequencies. So and that's only like maybe gosh, I don't know. It's like maybe only less than a quarter of a degree across for the molecular glass cloud. So that's going to, for whatever dish you have, it's probably a point source.
Yeah.
For practical purposes.
Well, and
So
it's a short baseline as well.
This is with tracking that object across the sky. No wonder the amplitude remains constant along there. If you did a drift scan across there, it would come and go with a nice Gaussian curve?
Correct, that's right. Yep. So
All right, good.
Yeah, so if I stop tracking, you'll see it tail off with that half a Gaussian curve.
Excellent stuff. Thank you.
Wow.
Okay, guys, I'm going to have to leave you.
Really
Thanks for
cool.
the meeting. It's been really interesting. I look forward to the next one.
Fantastic. Great having you taking part, Brett. Thank you very much for joining us.
Fantastic.
Cheers, guys.
Yeah.
See you.
Yeah, all the best, Brett. Bye-bye for now. Okay, so...
And he's where? Is he in Australia?
yes, he's at Newcastle, a couple of hours north of Sydney.
Wow. Yeah, that's kind of what I thought. Yeah.
Okay.
Okay. Well.
So I'm going to formally stop the meeting now, and say the next meeting's on the 27th of October.